Hi guys. We're gonna get right into slope formula. Today there was some tutorial questions and I decided that it'd probably benefit from reviewing it. So I won't be doing any practice problems here. That'll be in a separate video. This is just reviewing my PDF. So in case you guys are confused on what I'm trying to say or what I'm trying to explain. So obviously we have slope formula review here. Jump right in. So we have y equals mx plus b. This is what we call slope-intercept form. So this is just another way to write slope. All right, slope-intercept form is y equals mx plus b if you're ever asked for that. Each one here has its own meaning, right? That's why they're color-coded. So let's go over that real quick. Yellow. So first we have y. This is the answer to the function when given x. And all that means is that if you notice up here, there's an x. Y is the answer. If I tell you that x is, we'll just say 5, and then I tell you that m is a certain value and then b is a certain value, you should be able to give me y because you would just plug these into the function and that would give you an answer. That's actually how you check in problems where it says um which ordered pairs work with this slope. You guys had one on your test actually that was pretty similar to that. It'll give you ordered pairs. You just plug them in. You just plug in the x for the y. You just plug in the x. And then if you get the y, then you know that ordered pair works. If you plug in something for x and you get a different y than what the ordered pair is saying, you know that doesn't work. Okay? But in those scenarios, m and b are given. So let's go over what those mean. So m is actually your slope. We call that rise over run a lot of the time. It's just an easy way to remember it. Rise is how much you go up, and remember, you can also go down. Same thing with run. It can be positive or negative. So it's just however much your line is moving. You're able to tell m a lot of different ways. If you're given a graph, you can just count the squares. You can do the point slope. You can do the slope formula. And then you can also pull it from a table, but that also is just slope formula. Um, this right here, if you ever see this, plus or minus, all this is saying is that b can be either adding or subtracting. Obviously, that applies to m as well. M can be positive or negative, but I don't write it here because you would know that once you find it. The reason I write plus or minus is because y can equal a negative slope plus b. It can equal a negative slope minus b, or it can be a positive slope plus b, right? That's why I put the plus and minus there. That's all that means, is that this isn't fixed, right? Some formulas always add, like the quadratic formula. That's not the case here. It can either be positive or negative. Neither is wrong. This is obviously rise over run. So we could define rise as our change in y. That's what I was hinting at earlier by how much we increase or how much we decrease. Run is our change in x, as stated here. They're color coded. That's the only reason for the colors. There's nothing special about them. And then I have another note here about y-intercept. So if you're given a graph, the y-intercept is where our line is crossing the y-axis. That's why it can be positive or negative. Now, another thing that you guys might help you remember, the y-intercept is the value of y when x is 0. And the reason that works is because I'm just going to draw something here. Oh wow, it's tiny. You can only have a y-intercept at x being 0. That's the only spot this y-axis exists, right? There's no y-axis at x is equal to -3. There's no y-axis over here. It only exists at x being 0. So that's another way to remember that, right? If you see a nice graph, your y-intercept is going to be this point right here where it crosses the y-axis, or when x is 0. And that's pretty important to remember because what we're going to get into. So here I have an example that I'll just talk you guys through, right? The top right, this box is just to remember what these values mean, right? So given y equals 2x minus 1, identify the slope and y-intercept. So if you guys remember anything from what we just saw a few minutes ago, there's y, there's m, and there's b. You look at this top right box over here, b is our y-intercept and m is our slope. Okay, so if you guys understand that, you can probably skip ahead. There is something I would like to mention. You should note that unless m is written as rise over run in a fraction, you always assume the run is just 1. So in this case right here, this is not 2 over 4, 2 over 6. It's not something random. It's 2 over 1. If your run is something besides 1, you're going to see that, okay? It would be written as like 2 over 4. Well, this becomes 1/2 actually, but right, it would be something like 2 over 7. If it's just like 7x, right, this is always over 1. If it's just 8x, this is over 1. So our rise is 8, but our run is always 1 unless it tells you otherwise. That's just something that's important to know. Right, and as I just mentioned for our example, our rise is 2, and we assume our run is 1 because it's not stated anywhere else that it isn't. So y is only known when they tell you what x equals. Okay, so what I mean by that is, as it stands, you can't really solve this, but if I told you that x is 5 and I wanted you to tell me the y, all you would do is plug that in. So you would do, actually, let me change how bold my writing is. Right. Oh, that is way too bold. Right, so if I told you that x was 5, you would just plug it in. So instead of writing x, and then you would solve this to be y is equal to 10 minus 6, y is equal to 4. That means an ordered pair on this for this slope is 5, 4. Okay, so that's all that is. Now, let's continue. So as you can see here, our answer is y is equal to 2 over 1x minus 6. Now, I will note this, if you're taking a test where you need to write it, this might be marked as wrong. Like I said, I wrote 2 over 1 so you guys can see that. Ideally, if you're answering something, just leave it as this, okay? We're assuming it's over 1. It's really pointless to write it. I would always go with this type of answer over the other, all right? And obviously a little note here. Oh, incorrect thing. The line is crossing -6 on the graph. So that means like if you were choosing a graph that matches this slope, you should go with the one that crosses here at -6. And then if there's multiple answer choices that cross at -6, you want to choose the one that the points you can identify are up to, right, over 2, and 1 away. Obviously, I don't have a graph paper here, but that's just the gist of it. Sorry, you guys probably couldn't see half of that. Now let's move on to the next. Let me fix this paper here. Okay, so as I say on the paper, sometimes we're not always given a clear picture with an obvious slope, and that might be a shocker to you guys. Quizzes can be pretty difficult. So this here is what we're going to use when you're given a table or ordered pairs. This is, honestly, I'm forgetting the name. I'm blanking on that. It's just a slope formula, okay? M is equal to y2 minus y1 over x2 minus x1. This is fixed, okay? This is a formula. It doesn't ever change, all right? It's always subtraction. That's why I was hitting at earlier that I wrote plus or minus. This one is always subtracting, okay? Even if you have a negative for y1, you put subtracting and then you fix your signage. And what I mean by that is that if your y1 is like, we'll say y2 is 10. You always write the subtraction and then you plug in your y1. So if we have -7, you do this and then you realize, okay, this is 10 plus 7 because the two negatives cancel out, okay? You don't ever write 10 plus because this isn't the slope formula. This is something you're doing on your own, Okay, this formula is always fixed to be a subtraction sign here, and then you plug in your y1. And obviously, if y1 was positive 7, you just plug it in directly, and now your answer is 3. So please keep that in mind. Don't mess that up, please. And I note here, this also applies when you're given a table. And what I mean specifically by that is this over here. Okay, when we walk through this, we're doing an ordered pair, but the thing is, sorry, an ordered pair comes from tables in the first place. So if I'm given this table and what is it, I'm told to find the slope, I can choose any of these. Okay, and this I wrote here, this is my x1, y1, right? 2, 3, x2, y2, 5, 11. I could have chosen 2, 3 to be my x1, y1, and 8 and 19 to be my x2, y2. I could have chosen 5 and 11 to be my x1, y1, and my next point to be x2, y2. You don't really have a set way to choose, right? Ideally, just choose what comes first and what comes after. Okay, don't choose like 8, 19, and then choose 2 and 3 to be your second ones. You might confuse yourself because, like I said, it's just plugging into a formula. So the reason I highlighted that is because, like I said, in our example here, I give you guys this question. Find the slope of a line with points 3, 4, and 7, 10. These are already ordered pairs, but you could have pulled these off a table, right? So when we walk through, just keep that in mind. This also works for a table. You just have to get these yourself. So the first step is to identify your points. I mentioned here, I usually always assign x1 and y1 to the numbers the problem gives first. So if you read the problem again, that's this, okay? So as you can see here, x1, y1 are 3 and 4. And then just as it gives us 7 and 10 second, that is these, okay? Always just a preference. Next, you literally just plug them in. So m is equal to x2 minus y1. I mean, y2 minus y1, right? If you're confused on where these numbers are coming from, it's just what we got right now. 4 is coming from y1, and 10 is coming from y2, okay? You're just plugging in. And obviously, that's the same for the bottom. These are your x's. And like I said, this is a formula, so your x's are always on the bottom, your y's are always up top, and the first one is always y2. Keep in mind, I'm subtracting. That never changes. And obviously, that gives us that m is equal to 6 over 4. I just subtracted. Hopefully, we can all do that, you know? And then next, I would always recommend you try to reduce. Sometimes you don't have to. You're not wrong unless the problem tells you you need to be in the simplest form. The thing is, though, later on, you might have to draw the graph that matches your slope. And drawing a point with the rise, with your rise run being 6 over 4, gives you a lot bigger of a graph than reducing to 3 over 2. Okay? None of that makes sense to you. Just forget about it. It'll come later. But obviously, I'm sure there's some of you that's saying, well, what about my y-intercept, right? Because I mentioned earlier, that's part of point slope formula. And I guess I should emphasize now, there's plenty of different ways you can get problems regarding slope. Almost all of them are solvable by multiple different methods, okay? So what I mean by that is if you are given a table and it wants you to find the point slope formula, you need to refer back to the point slope formula, y equals mx plus b. So what we do is we arrange for b, okay? So if you look here, all I did was I subtract mx from one side, and whatever you do to one side, you do to the other. That gives you y minus mx on this side is equal to b, because b is the only thing left over here, right? So if you notice, this is why you guys learn concepts in little parts. This is just solving for x in a applied differently, right? This is technically just solving for b. And then all that's left is you plug in your values of the ordered pair. So if you notice, 3 and 4 looks familiar because I'm using the ordered pair the problem gave. And then I just plug in everything I know. So y is 4 here. That's why it's here. Because if you look, that's where y is at. 3 over 2 is the m we found right here. Okay, it's just coming all together here. The 3 is just, oh, sorry. the 3 is just that 3 from the ordered pair. And obviously we don't know B. I just plug this directly into a calculator. All right. If you want to know how you would do this without one, 3 over 2 is 1.5. You can do that in a division table. 1.5 times 3 is 4.5. 4 minus 4.5 is negative 0.5. Okay. So that's my y-intercept. So I notice here I didn't write it. That means your final equation would be y is equal to 3 over 2x minus 0.5. Okay. That's your final answer when you put it all together. Here is the slope from a graph. Okay. I guess I should mention that graphs are always read from left to right. So just think of it as a roller coaster. Okay. The roller coaster starts on the left over here. So you know the slope is going to be negative. That's why we read it from left to right. Because if I read it from right to left, I would think this is positive. That is wrong. You notice here, this is what I mean when I say counting like nice points. Right here, I can obviously see that if I go down one and right one, I get another point on the line. It's not always the case. That's why we need to know all these different methods. Oh, did I just mess up my? No. Nope. Sorry, guys. Still getting the hang of this. So when I say the first step is looking at the nice points, I'm referring to those points on the graph. Identifying the rise over run, right? I just mentioned to you, you're going down one and you're going right one. Just plug that in. Rise over run, -1 over 1. It's negative because we went down. And you identify the y-intercept. So on this graph, you can visually see where the y-intercept is. It's 3. Okay, it's where it crosses. And you just put it together. Okay, so y is equal to mx plus b, y is equal to -1 over 1x plus 3. That is unnecessary. You can just write y is equal to -1x plus 3 because we're assuming that -1 is over a 1. And here I just provided a short summary, right? This is what rise over run is. Slope is your change in y and change in x. Here's a little quick example, right? In the change in y, here's -6 because we're going down. And then the run was 3, so that's your slope right there. And this one, it's 6 over 2. And this is just repeating what we learned earlier, all right? If you guys would like me to work through plenty of problems, I will. I plan on it. But if not, then obviously I just won't do it. Also, I guess it's important to mention, if you're not an Avid and you're watching this, if you come in during lunch, there are plenty of tutors available to help you. Okay. I usually sit at lunch and nobody comes in. All right. So don't be afraid to. If you need help, you need help. But that's all I really have. Like I said, if you're an Avid, please don't forget your name's being in pen. Don't forget that you can do a Foursquare and get your button checks done over the weekend. So thank you guys.